must be. We are going to look at organizing data, and the reason is because there's many ways to organize data. But our goal is to, when we see data, be able to look at it. You want to be able to organize it, and then say, hey, I see something within this list of numbers. I see something because I've organized it. It makes sense. There's a pattern or something else. I found some piece of information specific. So let's take a look at the following example. The employees at a computer company listed the estimated distance from their home to work in miles. Use a line plot to organize the given data. So here I've got a bunch of data. Right now it's just a big grid of numbers, but let's see if you're able to make some meaning from this grid or that data. So here you notice that the smallest distance is 5 miles, and it looks like the greatest distance is 45 miles. I'm going to create my box here, change my tool up. Here at distance, I'm going to change the color for a second. I have distance and frequency, I'm going to call it. So distance, frequency. Let's see what I can do here. Should be using yellow. So I'm just going to start plotting values in now. Say 5, 10, 15, 20, 25, 30, 35, 40, and 45. Now I have my miles plotted, but now let's count the frequency. That means how many times does this number appear on the list? Well, I can count all the fives. That's a pretty easy one. It stands out. I'm going to change colors for this guy. All the five, just once. Just one time. Now the 10's a little bit different. I got 1, 2, 3, and 4. So 4 10s. How many 15s do I have? I got 1, 2, and 3. How many 20s? 1, 2, 3 20s. 25s, 0 25s, about 30s. I got 1, 2, and how many 35s? 1 35, 40s. 40 appears once, and also 45 appears one time. And this last box isn't needed, so I'm just going to scribble it out. And then the problem actually says use a line plot, so that's what we'll do next here. And what's a line plot actually? Well, a line plot uses a number line to show how often these values occur in a set of data. So I'm just representing this visually a different way. We could say down here, I got 5, 10, 5, 10, 15, 20, 25, 30, 35, 40, 45. That looks like a 9. Okay, so again, a line plot, it actually uses a number line like the one I have below to show how often the values occur in a set of data. So for 5, I'm gonna represent my line plot how many times the value occurs using an x. 5 only appears once, so it only occurs once. So I'm going to use 1x. That's a terrible x. So I'm going to fix that here and say, well, 10 occurred 4 times. So now I'm going to make 4 x's. You kind of want them to be in sync with the others. 1, 2, 3, 4. Now 15 appears 3 times. 1, 2, 3. 20 also appears 3 times. Those are terrible x's. Got to fix them. And 25 appears 0 times. I'll leave that one. And 30, moving on to the next one. Since I had none at 25, I got 2 at 30. So I'll do 2x's there. Having some pen troubles here, but I'll fix it. There we go. Then 35 had 1, 40 had 1, 45 also had 1. So here with the line plot, you actually can see visually what we couldn't gain in this mess of numbers, just this whole box here of values spitted out at you. But here within the line plot, you can say, hey, you know what? I have this huge spike at 10 miles, and then also at 15 miles and 20 miles. So for this computer company, most of the people that work for them live between 10 to 20 miles away, and then um, no one lives too much further out from there. There's a couple of people, and then also within boundaries, no one lives too close. So you can really see a good visual that you would not have gotten from just a big box of numbers. Neat.